In the video up here on Plug and Play, we talked about system resources. We also mentioned several other things that the Plug and Play system sets up for us. I'm just going to choose a driver down here and say Properties here in the Device Manager, and you'll see, for example, we mentioned that power management is set up, the drivers are chosen, and those files are moved. So these are some of the things that are done here, and we're going to look at these in more detail later on. But one of the things that it does is set up system resources. And in this case, you see some such as the memory range and IRQ numbers. Now, what in the world is all that talking about? Well, let's look at these. There are 4 system resources that a device may use, or I like to say abscond. I like to take over these system resources and use them. One is an IRQ number, or an interrupt request. I should have bolded that there. The interrupt request. The interrupt request is a number given to that device, associated by Windows to that device, such that when this device needs the CPU's attention, it can send it this number, and then the CPU knows by that number which device it is that needs that attention. So, for example, let's say I'm doing a download from the internet, or a copy and paste of a very large file or folder, and I press a key on the keyboard. Well, the keyboard needs to get the CPU's attention and say, hey, stop what you're doing and listen to me. Because it could be that, for example, I'm trying to cancel the download or the copy. So it needs to listen to that keyboard press. So it would send, the keyboard, by the way, uses IRQ1 almost always. So in this case, it would send a 1 to the CPU, and the CPU says, oh, a 1. That means I better listen. There's a key press that I need to listen to. The next one is direct memory access. And this is a channel number by which that device can move information directly to memory. That's why it's called direct memory access. This channel number is assigned to the device and says, hey, once you start, say, a transfer with a storage device, if I begin copying, I don't need to use the CPU for every bit and byte of information. I'll use the CPU at the beginning to begin the transfer, and then it can just switch over to this channel and send information directly to memory rather than having to go through the CPU. So that saves a lot of CPU time. The third one is the I/O port. Now this is kind of the opposite of the IRQ. In the case of the I/O port, it's a number assigned to that device that the CPU uses when it needs to get the device's attention. So if a CPU needs a particular disk drive, it can use the I/O port number for that disk drive, send that out over the line, and when the disk drive sees that number, it says, oh, you need my attention, what do you need? And we'll listen to the CPU. So it's the opposite of the IRQ. The last one are memory addresses, and it turns out that some devices are designed such that they need a certain area of RAM to load information about that device. And so these are the static memory addresses that are set aside by that device for use in RAM, so that part of RAM is not given to other uses. So those are the 4 system resources. Now, it is important to understand that not every device uses all 4 of these. In fact, some devices don't use any of these. Some will use all 4 of them, and some may use only 1, 2, or 3 of them. So you won't find the tab, for example. I don't know why I keep going back here. I need to keep that device manager up. Device manager. You will find that some items in the device manager do not have, let's click one of them here. I believe this one doesn't even have a system resources tab. Others do. By the way, just because it doesn't have one doesn't mean it doesn't use system resources, but often it's listed as one of the properties in a device driver. Alright, so that's it for system resources. Next, we're going to start looking at Bluetooth.